Good morning, everybody. We are doing 3.3 today, which is on multiplying and dividing with radicals. And multiplication of expressions that contain radicals is very similar to multiplication of polynomials. So let's take a look at this polynomial right here. I'm going to do it the longest way possible so you see how it works. Okay, so the first thing I'm going to do is everything in here is being multiplied together, so I am going to rearrange it and put the 3 times the 2 times the x times the x squared, and I'm going to group them like this. So I used my commutative and associative properties to rewrite it and regroup it. Then 3 times 2 gives me a 6, and x times x squared will give me x cubed. Okay, so the same process works for multiplying radicals here. So what I would do here is put the 3 times the 2 next to each other, then the square root of 5 times the square root of 7 over here. 3 times 2 gives me a 6, and the square root of 5 times square root of 7, they have the same index and it's being multiplied together, so we can use the product rule for radicals to put these guys underneath one radical. So remember, the product rule is like the nth root of a times the nth root of b equals the nth root of a times b. Okay, so I can put this together. It'll be square root of 35. So 6 square root of 35 is your answer there. Okay, this one here, this really means, well, what you could do here is square each part of this, okay? So I have 2 parts here. If I square the 2, I'll get a 4. If I square the square root of 3x, remember those guys are opposite operations, so they cancel each other out, and I'd get a 3x. Multiply those guys together, and that would give me a 12x. Okay, let's look at this a different way. I could have also written this as 2 square root of 3x times 2 square root of 3x. Okay, that says this twice, right? Then rearrange it. I get 2 times 2 square root of 3x times square root of 3x. 2 times 2 is 4. Then square root of 3x times square root of 3x would give me the square root of 9x squared. And square root of 9 is a 3. Square root of x squared is x. I still have that 4 over there, and that would give me a 12x when I multiply that together. Okay. Let's do this one here. Square root of 3 times square root of 12, same index, it's being multiplied together. I can write it under one radical, square root of 36. Okay, then square root of 3 times a negative 4 will give me a negative 4 square root of 3. Square root of 36 is 6. And we have to clean that up because remember, we're not allowed to have a perfect nth power underneath the radical. Minus 4 square root of 3. And that's it. So we did here, we did a monomial times a binomial. And you cannot add those guys together because they are not like terms. Down here, we're doing a binomial times a binomial. So I'm going to distribute all of this with those guys there. So basically, I'm foiling this out, okay? So I'm going to go this times this. That'll give me 4 square root of 9, because square root of 3 times square root of 3 is square root of 9. Square root of 3 times a negative square root of 5 will give me a negative square root of 15. Okay, square root of 5 times 4 square root of 3 will give me a positive 4 square root of 15. Square root of 5 times a negative square root of 5 will give me a negative square root of 25. All right, now let's go and clean it up. So a 9 square root of 9 really is 3. So 4 times 3 is going to give me a 12. These guys here are like terms, aren't they? Like terms, same index, same radicand. And do not forget that there is a implied 1 in front of there. So if I have like terms, I add together those coefficients. So -1 plus 4 is going to give me a positive 3. Then use your like term right behind it. And square root of 25 gives me a 5. So that's going to be a -5 back there. Well, now these guys right here are like terms. Okay, so we have 12 minus the 5 is going to be a 7 plus 3 square root of 15. And do not go any further because they are not like terms. All right, let's try another one here. This really means this, right? Okay, now distribute, and I am going to FOIL it out. So square root of x times square root of x will give me the square root of x squared. Square root of x times 3 will give me a positive 3 square root of x. A 3 times square root of x will give me a positive 3 square root of x. And 3 times 3 gives me a 9. Okay, so let's clean that up. Square root of an x squared. Those guys will cancel each other out, leave me an x. These guys here are like terms, right? So add together the coefficients there. So plus 6 square root of x. And then I have the plus 9 on the back there. And that is it. Okay, next one here. First thing I notice when I'm looking at this is I have exactly the same thing but opposite signs. And remember, when we have that, we will lose our middle term. So I'm actually going to do this one twice so you can see how that works. So first way, I'm going to do it the longest way possible. I'm going to FOIL it out, okay? So that'll give me a 9. That gives me a positive 3 square root of x. This gives me a negative 3 square root of x. And this gives me negative square root of x squared. Okay, so I got a 9 here. Those guys are like terms, and they are opposites, so they cancel each other out. Then back here, I'll have a minus, and a square root of x squared is going to be an x. So 9 minus x is my answer on that. Let's do it again. I know that I'm not going to have a middle term, right? So all that I have to do is this part and this part. 3 times 3 gives me the 9. Then I have a negative square root of x squared when I multiply those together. Then I'll have 9 minus square root of x squared will be an x. And there you go. It'll save you a little bit of time if you do it this way. Okay, so here we are. Another one of these looks just like this. And I notice that they're basically the same thing except for opposite signs. So I only have to do this part and this part because I know my middle term will go away. So 6 times 6 gives me 36. Square root of 3 times a negative square root of 3 will give me a negative square root of 9. And square root of 9 is a 3. So now I have 36 minus 3, which will give me 33. All right, so these are conjugates, all right? Conjugates, in general, the conjugate of the square root of a plus the square root of b is square root of a minus square root of b. Notice it's the exact same thing, just the opposite sign. So if you started with this, that would be the conjugate. If you start with this, That's the conjugate, opposite signs there. Multiplying conjugate always produces a rational number. Okay, so let's take a look at this one right here. I'm starting with this. So what is the conjugate of that? Well, it is going to be the square root of 12 plus the square root of 3. Then when I do the math on that, I solve it. Let's find out what we got. So square root of 12 times square root of 12. Well, isn't that just going to be 12? Okay. It would be the square root of 144, and the square root of 144 is 12. When I have those are the same thing, it just comes out to be 12 because it would be 12 squared. Okay, minus, it's always minus here, right? Because negative times the positive. And then I'm going to do this part right here. So square root of 3 times square root of 3 gives me square root of 9, which is 3. 12 minus 3 is 9. Okay? So notice I started out with the radicals. I multiply by the conjugate. I get a rational number. Okay? Let's take a look at this next one here. Starting with this, let's find the conjugate. Square root of 3 minus 2. Okay? I know the middle term's going to drop out, so I'm not even going to bother trying to find that. Square root of 3 times square root of 3 gives me square root of 9, which is 3. Then I have the 2 times a negative 2, which will give me a negative 4. So the conjugate in this case is a negative 1. All right. Well, conjugate's not a negative 1. Conjugate's this. When you solve it, it's negative 1. Okay, let's take a look at this next one. So the conjugate would be 2 square root of x minus square root of y. Okay, I know the middle term's going to go away. Don't need to try to find it. So this times this is going to give me a 4x. This is always minus. Then this times this is going to give me a y. So this one equals 4x minus y. Conjugate down here on this one would be square root of 3 plus square root of 7. Square root of 3 times square root of 3 gives me a 3. It's always a minus. Square root of 7 times square root of 7 gives me a 7. That's going to give me a negative 4. All right, so those are conjugates. Now we're going to do division with radicals. And I know I did a few of these the other day, but we're going to do a few more. And just remind you the quotient rule here that states if we have the nth root of a over b, remember we cannot have a fraction underneath the radical. That's breaking a rule. So we need to break this apart, and it would be the nth root of a over the nth root of b. This again is breaking a rule, so we're going to have to clean that up. And in this case, b cannot equal 0. We can't have a 0 in the denominator. Okay, so let's break this one up here. It's breaking a rule. We can't have a fraction underneath the radical. So this would be square root of 1 over the square root of 2. Okay, so I can't have that square root of 2 down there. That's breaking a rule. So I am going to have to clean that up. Okay, and to do that, I am going to multiply by square root of 2 over square root of 2. Remember, we want to make a perfect square using 2. So a number that is on my square list. And I'm starting with a 2, and I notice if I multiply it by another 2, I can get up to 4. Okay, multiplying by square root of 2 over 2 is the same thing as multiplying by 1. It's not going to change the value. Multiply straight across. Now I can do this because of the product rule, same index being multiplied. So that'll give me a square root of 2. And here, if I have square root of 2 times the square root of 2, that is going to give me square root of 4, and square root of 4 is 2. All right, this 2 is not underneath the radical, so you cannot cancel those out. That is your answer right there. Okay, this next one here. Well, first thing I notice here is 5 goes in here once, 5 goes in here twice. Then I'm thinking, hey, I can do a little bit of work under here if I put it under one radical. And I can do it because it has the same index there. So this will be a 2. Then I'll have that over 15 over 3. Okay, so 2 times square root of 15 over 3. And that will give me 2. And 15 over 3 is 5. And that's as far as I can go on that one. Okay, because 5 is not found on my square root table over there. So that's it for that one. Okay, let's try another one. Now these guys are the ones that get a little hard for some people. Okay, so breaking a rule, I got a fraction underneath there. So I'm going to go, okay, cube root of 1, cube root of 4. All right, let's see if we can make a cube using 4. Oh, if I multiply it by 2, I can get up to 8. So let's multiply both top and bottom by the 2, cube root of 2. Okay, multiply straight across there. That's going to give me a cube root of 2. Same index multiplied. We can do that. Okay, then down here, same index being multiplied. So that would give me the cube root of 8. And the cube root of 8 is 2. And there's nothing I can do with that. So cube root of 2. All right, next one. Breaking a rule, can't have that. So I got a cube root of 1, or cube root of 1 up here, and a cube root of 2 down here. All right, I want to make a perfect cube using the 2, and 8's going to work again. So to get that 2 up to an 8, I need to multiply by cube root of 4. Okay, multiply straight across, same index being multiplied together, we can do this. So cube root of 4, this will give me a cube root of 8, cube root of 4, there's nothing we can do with that. Cube root of 8 is 2, and that's it. Now in all of these cases right here, I had just a single term in the denominator, okay? Well, over here, I have 2 terms in the denominator. So I need to clean this up. And when I clean it up, we call it rationalizing the denominator. Okay, so let's get that cleaned up here. Let me get my notes. Okay, so to rationalize the denominator, this one's breaking a rule, right? I'm not allowed to have a radical in the denominator. Well, to get rid of that, what I'm going to do is use the conjugate, okay? So I am going to multiply this by 3 square root of 2 minus 4, both top and bottom. That way I'm multiplying by 1 and will not be changing the value, okay? That's 1. All right, I always like to do the bottom first because when I do that, you know, something might cancel out. Okay, so I know my middle term's going to go away. I'm not even going to try to find it. That'll give me 9 square root of 4 minus 16. Okay, square root of 4 is 2, so that's 9 times 2 is going to give me an 18 minus the 16, so that equals 2. All right, keep track of this. That 2 needs to end up in the denominator, okay? Then I come up here and I need to distribute this. Oh, actually, couldn't I cross cancel? This is in the denominator, I can do that. So 2 goes in here once, goes in here 4 times. All right, now all they have to do is distribute that 4. So this is going to give me a 12 square root of 2 minus 16. and that is it. Okay, you cannot go any further because they are not like terms, so do not combine those. All right, let's take a look at this one. It's breaking a rule. I got radicals in the denominator, not allowed to have that. The way to get rid of it is multiply by the conjugate. So square root of 6 plus square root of 3, top and bottom. Multiplying by 1, okay, and I'm going to put everything in here in parentheses, and in this case we've got to distribute, so I'm going to FOIL it out. But this one down here, I know the middle term's gone, so that's going to give me a 6 minus 3, so that equals 3. Okay, there's my denominator. In this case, I cannot cross cancel anything, you know, because, well, that plus sign, can't do it. Okay, so let's FOIL this out up here. That gives me a 2 square root of 6 plus 2 square root of 3 plus square root of 30 plus square root of 15. All over R3. Okay, you know what? That's it. We cannot go any further. None of these are like terms at this point, right? 6, it's not on my square root list. I can't take it out from underneath. 3, can't do anything with that. 30, what would that be? 3, okay, so 30 would be 3 times 10, and 10 is 5 times 2. There is nothing I can do with that square root of 30. And this one here would be 5 times 3. Yeah, that's it. Okay, so that would be my answer right there. Okay, let's take a look at this next one. Again, got a radical in the denominator. Need to use the conjugate to rationalize that denominator. Same thing, top and bottom. Okay, put this in some parentheses there. Square root of 6 times square root of 6 gives me a 6 minus 9 times 9 gives me an 81. Okay, 6 minus 81 is negative 75. All right, so there's my denominator. Don't want to lose track of that. So square root of 3 times square root of 6 will give me what? A square root of 18. And square root of 3 times 9 will give me plus 9 square root of 3. Okay. All over my negative 75. Well, 18, isn't 18 really a 9 times 2? There's nothing I can do with that one. So here I'll get square root of 9 gives me a 3. Square root of 2, can't do a thing with it. So 3 square root of 2 is what that one turns into. Plus, nothing I can do over here. 9 square root of 3 over that negative 75. Now you might think you're done, but you'd be wrong, okay? Notice I have a common factor here of 3. 3 will go into all of those. So I'm going to factor out a 3, and I will get square root of 2 plus 3 square root of 3. Notice I don't factor it out of here, okay? Only the coefficient. So if I distribute that, it gives me 3 square root of 2. If I distribute that over here, it'll give me 9 square root of 3 over 3 times a negative 25. Okay, so these guys will cancel, and I'm going to move the negative sign up top, and I'll have square root of 2 plus 3 square root of 3 over my 25. Okay. All right, so, you know, anytime you have a fraction, you always got to look to see if you can reduce it down. Okay, next one here. Got a radical in the denominator, breaking a rule. I'm going to rationalize the denominator, by multiplying by the conjugate. Here we go. I'm going to put everything in parentheses. Then I'm going to start FOILing out, okay? So that gives me an x minus 9. That is my denominator. Then over here, that'll give me an x plus 3 square root of x plus 2 square root of x plus 6. All right, and that's over my denominator here, but I want to clean this up a little bit first. I can combine those guys. I'll get x plus 5 square root of x plus 6 over x minus 9, and that is it. All right, we are done with, what is that, 3.3. Good luck on the homework and have a great day. Bye.